Good morning. Today we're going to look at notes, relations, and functions. So what we're doing today, we can analyze relations by matching graphs to their descriptions, classify data as discrete or continuous, classify relations as functions or not, and identify the independent and the dependent variables. So graphs are a great way to represent relations by turning words into pictures. We always read graphs from left to right. So if I look at this increasing graph right here and I add some variables, let's say this is going to be time, and on the y-axis is going to be distance. So I can say as the time increases, okay, so as the time increases, we're going up from left to right, okay. Let's see. As the time increases, the distance, okay, so we had to look at the graph up here. Is the distance going up or is the distance going down? Well, the distance is going up because the slope of this line is positive. So we would say that the distance increases. So the time increases and the distance increases. Let's do the same thing over here. Again, we're going to make this the time, and we'll make this the distance. So as my time, my x-axis increases, so let me write that down, as the time increases. Okay, so now let's go back and look at the graph. As the distance increases, what's happening to this distance right here? Okay, well, the distance is going down, right? So if I started at 10 up here, I'm now down to 2. Well, you can't read that. Hang on a second. I can't read that. This is 10 and this is 2. Whereas over here, if I started at 2, I went up to 10. Now I'm starting at 10 and going down to 2. So as the time increases, we're going to say the distance decreases. Okay, and let's look at the last one. We've got time and distance. So we're going to start that off again as time increases. Okay, so as I look from left to right at the time here, what's happening on this distance? Is the distance going up? Is the distance going down, or is it staying the same? That's right, the distance is staying the same. So I'm going to say the distance remains constant. Constant is just a fancy word for stays the same. Okay, so real quick on your practice, if we look at number 1, all right, so Robert graphed the trip he took on Labor Day. Try to describe each part of the trip. So we've got time on the x-axis, so we're looking at time increasing. So let's look down here. Time is on the x-axis, so we're looking at time increasing. Let's look at A. Okay, so on A, does the distance from his grandma's house increase or decrease, or does it stay the same? That's right, it stays the same. So this is the time that Robert spent at grandma's house. So if I look at this graph, okay, so wherever grandma's house is, Robert was at grandma's house for this amount of time. And then let's see, the formula, or the y-axis, not the formula, the y-axis says the distance from home in miles. So grandma's house is so many miles away from the home. And then on B, we turn around and do we go closer to grandma or do we go closer to home? The distance is decreasing, right? And we are distance from home and we're decreasing, so we're going closer to home. So let's write that down over here. So over here, I would say, let me highlight for you. I would say that we are, we'll say driving. I guess we could be walking. We don't know how fast we're going. But I'll just write driving back home. Okay, so let's come back and see what happens at C. At C, we stop moving again, right? I'm at the same distance away from Grandma's house. Well, maybe I stopped at the store for a while, or maybe I stopped at a light. But for some reason, we're stopped a little bit away from Grandma's. We're stopped not quite at home. I will put stopped at the store. Maybe I went to the park. I don't know, right? But we've stopped for some length of time. And then we had to drive. Again, we're moving again. So right here, we're moving. And now this distance is increasing. So the distance from home is increasing, and I'm going back towards Grandma's house. Okay, so this D distance right here is we are driving toward Grandma's house. Or we can say the distance from home is increasing. Or the distance from home is increasing. Okay, here we go. And let's look at the next one right here at E. Well, at E, we stopped again, right? We're not moving. We're not getting farther from home or closer to Grandma. We're not getting closer to home. Okay, so we've stopped again. Maybe I'm now stopped at a light or a stop sign. Or maybe I went to another store real quick. I don't know, but I've stopped. I'm not moving. All right, and on the last home stretch here, we're going to go purple. On the last home stretch, I have driven the rest of the way back to the house. Okay, so I have driven home. Okay, or that's the distance that I am now back at the home. Okay, so you guys have a couple of these where you're just going to match the graph. So what you're doing here is they give me a graph right here, and I'm going to go see, okay, well, is graph A going to match 2, going to match 3, going to match 4? So let's see, the temperature decreases, and then it stays the same. So this one says the temperature of the water in a grass remains constant. Well, no, this one decreases before it remains constant. The temperature of the water rose steadily for several hours until it reached room temperature and then remained constant. No, it didn't rise, it decreased. So number 4 says the temperature of the water cooled slightly. Okay, steadily, sorry, that's the steadily. With the addition of ice and then remained constant once all the ice had melted. So I've cooled. Temperature going down would be cooling. So I'm going to put graph A on that line. And you guys can figure out which one's B and which one's C, and you've got some more situations. And here you're looking at the situation and then deciding which graph matches the situation. Okay, let me go back to the notes for a minute. Here we go. If I'm going to try to decide if data is continuous or discrete, the question to ask myself is, is it possible to have just a part of what this question is talking about? Can I have just a piece of it? Okay, so let's look at a couple of examples. Discrete data is a set of distinct, separate values. There is clear space between one value and the next value. So for example, if I look at the number of songs downloaded, I did not spell downloaded right. Let's fix that. Downloaded. And the space available on my phone. Okay. Can I download half a song? I cannot. I cannot download half a song, so that would be discrete data. All right, another example. Let's see. The number of movies rented and the price paid. Okay, if I try to rent a movie on Amazon or on Prime, can I rent half a movie? No, I can't rent half a movie, so that would be discrete data. Okay, continuous data includes any value within the interval between any 2 points. There is an infinite number of other spaces. So for example, if I look at the time and the temperature of my drink. Okay, so if I go to Starbucks and get a coffee, my coffee starts off hot. Well, as time goes on, the temperature is going to decrease. Can I have half a minute? Sure. Can I have half a degree? Sure. So the amount of space between 1 minute and 2 minutes and 3 minutes and so on has an infinite number of temperature readings. So this would be continuous data. Okay. A second example is the time worked and the amount of money earned. So if I think about the time that I've spent working, can I work for half an hour? Yeah, I can work for half an hour and get paid for a half an hour. Can I earn half of a dollar? Sure, that's why we have cents, right? I can earn a penny if I work for a certain number of time. Okay, the independent and the dependent variable. The independent variable is typically my x value. Okay, so it's usually the x. It's often described as your input. This is the one that you choose, you change. You are the experimenter. It does not determine what's happening next. It does not depend on the other variable. Okay, so you're going to ask yourself, which variable doesn't depend on the other? What is causing the effect? So let's go back and let's look at some of my examples up here. So if I'm looking at the independent variable, okay, the independent variable is going to be my x, or my input. So let's see, the number of songs downloaded and the space available on my phone. Do I get to decide how many songs I download, or do I get to decide how much space I have? Well, I get to decide how many songs I've downloaded, so that's going to be my independent variable. The outcome of that, which is my dependent variable, so let's go ahead and write that down over here too. This is y, or f at x, or the output. The output, the dependent, is what we get out. After I've downloaded songs, I get out how much space I have left on my phone. Okay, so let's do the next one. The number of movies rented and the price paid. Well, I don't get to just decide how much I pay. I decide how many movies I want to rent, and the outcome of me renting a movie is I have to pay a price. Okay, let's look at the next one. The time and the temperature of the drink. Well, I can't control the time, right? The time just goes by. And then the temperature of the drink is a response to how much time's gone by. As my time increases, my coffee is going to get cooler. Or warmer, I guess, if I got an iced coffee. Okay, so let's see. The time worked. Okay, so the time is going to be what goes by. I can't change that. I can't control the time, right? Let's see. And then, well, I guess I control how many hours I work, right? So I decide I'm going to work for 10 hours. And then if I work for 10 hours, I get paid a certain amount of money. Okay, so let's look at a couple of examples of this. Number 12 over here on our notes. It says the air temperature increases steadily for several hours and then remains constant. At the end of the day, the temperature increased slightly before dropping sharply. So we're looking at number 12 here. And I need to decide what's my independent variable. So I've got two things that are happening. There's the temperature that's changing, and we're looking at a number of hours. Okay, so the air temperature and the number of hours. Which one of these is something that we either are deciding for the problem or we can't control at all? That's right. That's the time. So the independent variable here is going to be the time. The dependent variable, the outcome of time passing, is that the temperature is going to change. Okay, so what the temperature is depends on what time of day it is. So as the day gets longer, so in the morning it's 5 degrees, and as the day gets longer, it warms up, so the temperature increases throughout the day. Now, can I have half an hour? Sure. Can I have half a degree? Sure. So that makes this continuous data. Okay, let's look at my variables down here. I have $15 to spend on a movie, so money to spend. Each rental cost, so I have like each rental, the number of rentals that I can buy. All right, so let's think. What do I get to decide? I don't get to decide how much money they're going to charge me. I can decide how much money I can bring, but they're going to charge me for each rental. So I'm going to do right here, the number of rentals is going to be my independent variable. That's what I get to decide. I get to decide how many movies I rent, and the dependent variable is the money spent, right? How much money I spend depends on how many rentals I make. Well, I can't have half a rental. So if I can't have half a rental, that's going to be discrete data. Okay, so then there's a couple of examples for y'all to do right here. Okay, there's a couple of multiple choice, independent and dependent problems. You guys can pause the video and work on those. And the last thing that we're going to work on is it a function? And this should be a review. We've talked about this. A function is a special type of relation where each input, x value, corresponds to exactly one output, or y value. All functions are relations, but not all relations are functions. So let's look and see different ways that we can look to see if it's a function. Okay, so I've got 3, I've got 5, I've got -1, and I've got 5. All I'm looking at is the x values. Do any of these x values repeat? Yes, the 5 and the 5 repeats. So let me write this down. The x values repeat. X values repeat. If the x values are repeating, okay, so if my x values repeat, this is not a function. Okay, so if the x values repeat, it's not a function. So let's look at the next one. And again, all I'm worried about is the x values. So 0, 8, 2, and -3. Do any of those x values repeat? No. That's way too big. Hold on a second. Let me make that smaller. No x values repeat. Therefore, this is a function. So for this relation is a function. So let's go look at the table. Okay, so on the table, we're going to do the same thing. The x's are just written in a different way. So I'm going to look at 2, 3, 7, 9, 10. Okay, none of those x values repeat. So the x values do not repeat. Therefore, this is a function. Okay, this is what we call a mapping. 0 is mapped to the number 5. 1 is mapped to the number -3. So I guess I should write this. That means that this ordered pair is 0, 5. This ordered pair is 1, -4. Okay, and then it says 2 is mapped to 1. 2 is mapped to 1. So we would say that the ordered pair is 2, 1. And then we've got 2 mapped to 9. So we would say that the ordered pair is 2, 9. Now, if I look at these x values over here, this 2 and this 2 are repeating. The 2 has 2 numbers. It's going to 2 different numbers. That makes this 2 repeating. If the 2 is repeating, then this is not a function. Okay, I can also tell whether functions are, or rather, I can also tell whether graphs are function by using what we call the vertical line test. So if I draw a vertical line, see how I draw a vertical line here? Does the x value repeat? In other words, are there 2 points on that same vertical line? There are. So we would say this has repeating x values, so this is not a function. The x values are repeating. So let's look at this heart. If I draw a vertical line, does the x value repeat? Yes. So we would say that this is not a function. Okay, let's look at the last graph. If I draw a vertical line, does the x value repeat? It does not. I only touch 1 point, right? That vertical line only goes through 1 point. Whereas this vertical line is going through 2 points. That's why it's not a function. But if it only goes through 1 point, then yes, it is a function. Okay, so let's go back and look at your notes real quick, or your practice problems. Okay, so if they give me a set of points right here, I can write each one of these points as an x value and a y value. So the first number in the ordered pair is x, the second number is y. So x is -4 and y is 0. I can put -4 and map that to 0. I can come over here to the graph and put a point on -4, 0. Okay, the next point is x is -2, y is 2. So x is -2, y is 2. -2 is mapped to +2. And then I'm going to go graph -2 on x up to +2 on the y. And then the third point, x is 0, y is 4. So x is 0 and y is 4. 0 is mapped to 4. So I'm going to come over here to the graph. I'm going to do 0 up to 4. Okay, here we go. And the last point, the x value is 3, the y value is 4. So x is 3, y is 4. 3 is mapped to 4. 4 is a point on the graph. Now I can't connect the points on the graph unless I know what's happening between them. So I'm just going to leave them as points. And I'm going to come over here and answer this question. All I care about for is it a function is the x values repeating? So if I look at this x, this -2, this 0, and 3, none of these repeat, right? None of those are repeating. So yes, this is a function. And for explain, I'm going to write the x values do not repeat. Again, if any of the x values repeat, then this would not be a function. Now, if I go over here and look at my vertical line test, if I draw a vertical line, you can't see those vertical lines. Let me draw that again. If I draw a vertical line through each of these points, do these points go through, do these lines go through the points at more than 1? No. There is no repeating x value on each one of those vertical lines. All right, and I'll let you guys try the last couple. Make sure you get this turned in before the end of the period, and I will see you soon. Thank you so much. Have a good day. Bye.